Hey everyone, in this lesson we're going to be discussing how to find the volume of common three-dimensional figures. So I'm going to be going through the basic three-dimensional figures and I'm going to give you guys the formulas of how to find the volume and a really brief explanation about where those formulas come from. So let's start with the first one. The first one is talking about a cube. So for a cube, which is the first one that I have here, it's basically the formula is a to the power of 3, which is basically length times width times height, where all those are the exact same length. So therefore, it's just the same side, right? Length times width times height, multiplied all together. So that's the formula that they give us here. V is equal to a to the power of 3. The second one down the list is a rectangular prism, which is basically a fancy way of saying a box. Same thing as a cube, but the difference is that this is not a cube because not all the sides are the same. So they call it a rectangular prism, and it can vary depending on the values of the length, the width, and the height. So the formula for this is volume is equal to the length times width times the height. For a triangular prism, which is another way of saying a triangular box. So whenever I think of prism, I think of like some sort of box. Same idea here. We have the volume formula is base times height times L divided by 2, where as you can see, the base and the height are right there corresponding to the triangle, and the L is the length from the front to the back of that box. Then we have the formula for a cylinder. The formula for a cylinder is pi r squared times h. So pi is just a constant. R is the radius of that circle corresponding to the cylinder. And then height, the h is the height of the cylinder. Okay, next up we have a cone. The formula for a cone is pi r squared times h divided by 3. So basically same thing. The radius is the radius of the circle. The height is the height from the tip of the cone all the way to the center of the circle. And then you multiply that. Well, actually, you divide that by 3 after you multiply with the constant pi. Next, we have a pyramid, and the pyramid is, it looks like this. So it's, for obvious reasons, right? It looks like a pyramid. So the volume is equal to length times width times height divided by 3. And then the final one is a sphere. And the sphere formula is the only one that's unique. It's the volume is equal to 4/3 pi r to the power of 3. Okay, this is the formula. These are the formulas in the middle that are in a lot of math books, but I'm going to go ahead and explain this to you guys, like just dumb it down what it actually means. Because a lot of you guys already did area, right? And that's exactly what we're doing. So basically, let me go back and talk to you guys about area real quick. So I'm going to mark this up a little bit. So let's say we are talking about, let's go with box highlighter, see if that works. So let's say we're talking about one of these slices, right? So we're talking about, give me a second, this thing. Oh, it actually works, cool. I was trying to see if it'll allow me to highlight this, and it does. So find the area of one slice. So by one slice here in this case, it's equal to a box, right? So we find the area of that one slice or the box, and then we multiply it by the height or extrude it in engineering terms. And basically that gives you the three-dimensional shape. So you take one slice, which in this case is a box, find that box or the area of that box, and then you multiply it by the length, in this case by how deep the box is or the length from here to there, from the front to the back. And there you have it. That is the volume. And volume by definition is how much stuff can you fit in that shape. Same thing for a rectangular prism. A rectangular prism, if you slice it, if you take one slice, you actually get another rectangle, right? So if I were to take one slice, if I were to cut this with a knife, so every single one of these faces that you see here, one slice will be one rectangle. And then after that, you just multiply it by how deep the box goes in, or in this case, the distance from here to there, which would be whatever that distance is, or L. Okay? Same thing for a triangular prism, though. So now, the thing about a rectangular prism is that you need to know what the area is for that shape, which in this case, we all know that area of a rectangle is just base times height. Okay, so the L and the H, they're I mean, you could use them, but if you're more familiar with base times height, go ahead and do that also. Okay, now let's look at this shape right here, which happens to be a triangular prism. So a triangular prism, if I were to slice this, right? So if I were to take this shape and just get one slice, that will give you a triangle. If I want to find the area of a triangle, the area of a triangle is 1/2 base times height, which is basically this section here. And then all I have to do is multiply it by how deep it goes in, which will be the value L. So this is where all these formulas come from. And a lot of them are derived the same way. The next one is a cylinder. So maybe you won't tell me what the volume of a cylinder is, but you can tell me what the area of a circle is, right? So if I were to take one slice of this cylinder, meaning like if I were to take a knife and just slice it, like a ninja sword, just like whoosh. So now this slice would correspond to a circle. And maybe you might not be able to tell me or memorize the formula for a cylinder just yet, but you know what the area formula for a circle is, right? So for a circle, the area here is pi r squared. And if you notice, this volume formula, it's basically pi r squared, which is one slice, multiplied by how deep this cylinder goes, which is the height. So every single one of these formulas that we just talked about is one single slice, right? You take the area of one slice and then you multiply by how thick or how deep it actually goes in for every single one of these prisms or a cylinder or a cube, okay? And it applies for any of these shapes. As long as it's a prism and it goes all the way through the same way, or a cylinder, then it'll be the area of one slice multiplied by the depth or how deep it goes. Okay, this is where it starts to get a little bit different. So the cone is basically a third of what holds a third of what a cylinder holds. So if you already know the formula for a cylinder, basically this is just 1/3 of what a cylinder would hold. So if you know the formula for a cylinder or the volume of a cylinder is pi r squared times h, you basically just take that and divide it by 3 and that'll give you a cone. Pyramid, same exact thing. A pyramid, and we're going to prove this in class in the future. A pyramid is basically how much stuff can you hold inside of this thing. Would be the same thing as what you would hold inside of a rectangular prism or a box, right? So rectangular prism is just a fancy way of saying box. So this one right here. The difference is that we're actually going to be taking 1/3 of that also. So a pyramid holds 1/3 of what a rectangular prism holds. So that's where the formula comes from. So rectangular prism is just base times width times height, right? So L times W times H, but you take that and divide it by 3. So that is a rectangular prism, and then that's how it relates to a pyramid with the same area, base, and height. So the last one is a sphere. This one's the one that's unique. I really can't give you a relationship between a sphere. The only thing that I can say is that it holds twice as much as a cone. So it holds twice as much as a cone, but not as much as a cylinder. And it with the same base, area, and height. And the formula for that is 4/3 pi r cubed. Okay. Now that I went through explicitly about how to actually derive these volume formulas, let's actually do some examples. So little quick recap: volume is how much matter that three-dimensional shape can hold, and it is typically measured in units cubed, which means how many cubes of that size fit in that three-dimensional shape. For example, this is 1 meter cubed, and by that it's like 1 meter length, 1 meter width, and 1 meter for the height. So if you take 1 meter, 1 meter, 1 meter, and by the way, 1 meter is just about, it's a little bit more than a yard. If you just take a yard, which you all know what a yardstick looks like, and just add maybe like about your pinky's length, that's about a meter right there. So it's a yard plus about a pinky. So that is 1 meter cubed. Now, in science, if you take that meter and divide it by 10, you get a decimeter, right? A tenth of a meter. And that decimeter is actually the same thing as of saying 1 liter. And this is to scale right here. This is actually what it would look like to scale. So let me actually scale this down just a tad. So these are the three. So 1 meter cubed is on the left-hand side, which is right here. So the volume is 1 meter cubed. So that's massive, right? but this is actually 1 decimeter cubed, which is also known as 1 liter. 1 liter is 1/10 of a meter times 1/10 of a meter times 1/10 of a meter. And then finally, this is 1 centimeter cubed. So I actually have them here to scale, right? So notice that it's bigger and then it gets smaller, then it gets smaller. So whenever they write down, don't forget to write down the units because the units do matter, right? So when they're asking you how much stuff fits somewhere, like let's say for example, how much stuff fits in your room, it's if you say 100, well, 100 what? You know, that actually matters. If it's just 100 centimeters cubed, then you probably don't have a very big room. If it's 100 decimeters cubed, then you may have, you know, a decent sized room, or maybe not. And then 100 meters cubed, then you have a massive room. So units really do matter. So make sure you don't forget the units if they give them to you in the problem. Okay, so let's go through some examples. Example number 1. Find the volume of the compound figure, include units. Okay, I'm going to go ahead and do what I did in the beginning of the problem. I'm going to go ahead and mark this up. This is actually a prism, right? Prism is just a fancy way of saying box. More specifically, it's a triangular prism because what I can see is that one of these slices, right, which is the same all the way through, is a triangle. And I can actually verify this, right? If I just make a shape from here to there, from there to there, and then from here to there, no matter where I cut it, it's going to give me one of those triangles of the exact same distances. So the base and the height will be the same. So since I know that, basically all I need to know to find the volume is area of base times the height. So name of the shape, we already discussed that. This is a triangular prism. Oh, prism, or a triangular box. And the area of the base, in this case, the base would be right there, right? So this whole area, we know how to find the area of a triangle. The area of the base would be base times height divided by 2. And I wrote little b and little h, right? Little b and little h are 4 and 3. So the area of the base is 4 multiplied by 3 divided by 2. So therefore, the area of the base is equal to 12 divided by 2, which is equal to 6. Okay, so we have 6 miles squared. Mi stands for miles, so it's quite a huge triangle. Then we want to figure out the height, right? So the height would be how deep this thing goes in, so don't get it confused with the height of the triangle. How deep does this go in from there to there? That is the number that we need. And as you can see from the top portion is the exact same number, right? That is actually 8 miles. So this is 8 miles. So to find the volume is just the area of the base multiplied by the height. So the volume for this would be area of the base, which is 6 miles squared, multiplied by the height, which is 8 miles. So 6 times 8 is 48. So then the volume would be 48 miles cubed. Now, remember, every single time we're talking about volume, it's going to be to the power of 3 because we're talking about cubes. How many cubes would fit in that shape? And in this case, there are 48 cubes of 1 mile each that fit in this three-dimensional figure. Okay. All right. So hopefully that makes sense. The other ones are going to be pretty similar. Example number 2, find the volume of the compound figure, include units. So it doesn't matter how you slice it. I'm going to go ahead and take this thing and mark it up again and have one of these slices or a slice, right? So I'm going to go ahead and say that this section right here is going to be one of my slices. And then I'm going to be taking the area of the base, or capital B, so I can figure out my total volume. Okay, so the volume is equal to the area of the base multiplied by the height. And the area of the base is basically the area of one slice. And the height is how deep does it go. So in this case, we're talking about how deep it goes from here to there as the height, or the capital H. All right, so that being said, let's call this by a name. So this is just a box in geometry. To say a box, this is a prism. In this case, one of the slices is a triangle, or a rectangle, excuse me. So this is a rectangular prism. The area of the base is just base times height, right? So base times height is the area of the base. So if I find the area of the base, is just 7 times 5 yards, 7 yards times 5 yards. So it's equal to 35 yards squared. So I found the area of the base. Now I just have to figure out what is the height. Well, the height is already given to us in the problem. The height is actually 7, so that actually goes here. So to find the total volume, or actually I should write it down. It asks for it here. So the height is 7 yards. So to find the total volume, volume is equal to the area of the base, right? Capital B, area of the base, which is 35 yards squared, multiplied by the height. So that's one slice, right? That 35 yards squared is one slice. Now we just have to multiply it by how deep this thing actually goes in. And as you can see, this goes in 7 yards. So the final volume would be whatever that is, 35 times 7. Let me get my calculator here going. 35 times 7 is 245. So the volume for this is 245 yards to the power of 3, so yards cubed. So what that means is that if this box were in real life, 7 yards this way, 5 yards this way, and then 7 yards inwards, you would be able to fit cubes of you will be able to fit 245 cubes of 1 yard cubed each, if that makes sense. So 1 yard by 1 yard by 1 yard boxes, you're going to be able to fit 245 in there. Okay, example number 3. Find the volume of the compound figure and include units. So this is actually the exact same one that we had last time, so I'm going to run through it really, really quick. This is also a triangular prism. It looks like it. Let me make sure that it's not the exact same problem, just to be safe. 8343. Oh, yep, it is the exact same problem. That was probably a typo on my part, so I'm just going to go ahead and skip it. Next one, example 4. Find the volume of the compound figure, include units. So we want to figure out what is the volume of this shape. It says compound figure. I'm still using the one from the last lesson. So find the volume of the figure, include units. So let me just delete the whole compound. I think it's been saying compound this whole time. But anyways, you get the idea. So one of these slices for the cylinder is a circle. Now, even if you didn't know what the formula for the volume of a cylinder is, you know that the area of one of these slices, you know what that is, right? So this is B, right? And the area of the base is equal to, in this case, the base is a circle, so it will be equal to pi times the radius squared. So I know that the bottom is a circle, and I know that to find the area of a circle is pi times the radius squared. And they give us a radius is equal to 2, so I can basically find the area of that base or that bottom. So when I plug my numbers in, 3.14 is my pi, and then 2 is equal to my radius. I have to square that. So that's 3.14 multiplied by 4. I have to plug that in and simplify. 3.14 times 4. So let me get my calculator. 3.14 times 4 equals 12.56. So that would give me 12.56. There's no units, so I'm going to write units squared. I'm just going to leave it like that because they don't give us anything. So this is a cylinder. And the formula for a cylinder, I'm not even going to bother giving it to you, but it's actually right here. You just arrived it. So all we need to do, we take one slice, right? And then we multiply it by the height. So the formula for volume is equal to pi r squared, right? Multiplied by the height, which is h. So we already have the pi r squared. We just did it in earlier, right? So the 12.56 units squared, which is this section right here, that we just found. All we need to do is multiply it by 10, and then we're done, which is really, really simple because multiplying by 10 is not too bad. So 12.56 multiplied by 10, the volume for this cylinder would be 125.6 units. Don't forget the volume is in units cubed, right? So how many boxes can you fit? So in this cylinder, I can fit 125.6 boxes of whatever this unit is. So if we're talking about centimeters, then it will be centimeters. If we're talking about inches, it'll be inches. It can be miles, whatever that may be. Okay, example number 5. Again, there is no formula up there that'll tell you how to find like a shape that looks like this, right? So there's nothing that will give you a shape that looks like this. However, you're able to find it by using the same process that we've been using so far. So find the volume of the shape, right? So find the volume of the shape of the figure, three-dimensional figure. Include units. So I know for a fact that one of these faces is a trapezoid. And I know that because I did a bunch of area examples in the past, and I know this shape is called a trapezoid. So I can find the area of that base, right? That face. And then I can just take that face or that area and just multiply it by how deep this trapezoid goes inwards, which happens to correspond to this distance from here to there, which is 6 yards, right? So basically, if I were to take a wild guess, this is basically a box that one of the faces of the box is a trapezoid. So you guys are probably ahead of me. This is called a trapezoidal prism. So it's basically a three-dimensional box whose face is a trapezoid. The area of the base, if you remember the area of a trapezoid, so area of the base is 1/2 base times height, but in this case we have two bases, so 1/2 base 1 plus base 2 times the height. And then the height, or capital H, is basically how deep it actually goes. I'm going to go ahead and rename this as depth. And that depth is 6 yards. That way we don't confuse it with the little height, the height of that yellow trapezoid formula. So I'm only going to concentrate on this yellow trapezoid here. So basically concentrating on this trapezoid, I have to figure out, okay, what are the two bases that I'm going to be adding? What is the height that I'm going to need to use so I can find that area? Okay, so let's start with finding the area of that base. So 1/2 stays there. Base 1 plus base 2. So the base 1 is one of the bases, and the base 2 is the top base, which in this case happens to correspond with this 7 yards. That's the distance from here to there, which is the exact same as the distance from here to there. So same thing, I just moved it over forward so you guys can see it better. So I'm going to be adding the 3 and the 7, so 3 plus 7 yards, and multiply that by the height. Well, the height is the distance from here to there, which corresponds to 3.5 yards. Oh, thought I had to sneeze for a second. So from here to there, that is the height, right, of the trapezoid, which is 3.5 yards. So multiply this by 3.5 when you're done with it. So simplify, the base is equal to 1/2, 7 plus 3 is equal to 10. Multiply by 3.5. When I simplify this, I get 1/2 of 10 is equal to 5, or I can multiply, actually let's multiply these two together, that's easier. So it's 1/2 of 3.5 times 10 is just 35. So we have 1/2 multiplied by 35. So final base, half of 30 is 15, half of 5 is 2.5, so this will be 17.5. Don't forget that this is in yards squared, so I'm going to go ahead and write 17.5 yards squared. Are we done? No. What we just found the area of one slice, right? One of the base, that base right there is just one slice. So every single slice is a total area of 17.5 yards squared. But we want to find the volume. So we need to figure out, okay, we need to multiply that by how many slices there are, aka the depth. So the depth of this, we said earlier that it was going to be 6 yards, right? So 6 yards is the distance from here to there. So all we have to do is multiply that by 6. So the volume is the area of the base multiplied by the height, or the depth in this case. The area of the base is 17.5 yards squared, multiplied by how deep this goes, which is 6 yards. Calculator work, so 17.5 multiplied by 6. So 17.5 multiplied by 6. We get 105 yards to the power of 3. So the volume is 105 yards to the power of 3. This is my final answer here for volume. So the volume of this trapezoidal prism is 105 yards to the power of 3. So that means that 105 boxes of 1 yard cubed would fit in this trapezoid according to the dimensions. Okay, I do have a couple of more examples. The other couple of examples are just very straightforward, plugging into the formula. So example number 6, find the volume of the, okay, I hate that it says compound figure. Find the volume of the three-dimensional shape. In this case, the three-dimensional shape is called a pyramid. And one of the slices of this pyramid is a triangle. So what do you guys think this is called? So it is not a rectangular pyramid. It is called a triangular pyramid because one of the slices corresponds to a triangle. So the formula for that is basically the same thing that we had earlier. Area of the base multiplied by the height, but then we're going to divide that by 3 because basically a pyramid fits 1/3 of what a prism does. So once you find one slice and then you multiply it by the height, you just divide it by 3 at the end. So the same thing that we were doing before, but at the end you just divide by 3. So let's see what this actually means in terms of what I have labeled here. So first let's find the area of the base, aka let's find the area of this little triangle here. So the area of the base, I'll do it up here, for this triangle is 1/2 the base times the height, right? So since I know the base and the base in this case would be 6 feet and the height in this case would be 8 feet. So this will corresponds to 1/2 times 6 times 8. So this is going to give me 1/2 of 48, which corresponds to 24 feet squared. So then I have my area of my base. So my area of my base is 24 feet squared. That means that one of these slices, one of these triangular slices, has an area of 24 feet squared. Okay, so that's all we've gotten so far. Now we're going to take that and multiply it by the height and divide it by 3, as per my formula says. So the height in this case is all the way to the tip of that pyramid, from the bottom of the pyramid to the top of that pyramid, and they give us that is equal to 12 feet, right? So from the top of the pyramid to the tip of the pyramid, to the bottom, is equal to 12 feet. So all we have to do now is plug it into the formula. So, I think I messed up the formula too. So that formula is not for area, it is for volume because that's what they're asking us. So the volume of this shape is the area of the base times the height divided by 3. So good thing I caught that. So that'll give me 24 feet squared multiplied by the height, which we said was 12. And then we're going to take that and divide it all by 3. So the rest is calculator work. So the volume is equal to 24 times 12 divided by 3. You can do this any order that you want. I'm going to go ahead and just cheat and say, okay, I'm just going to divide the 12 by 3 first. So the volume will be 24 feet squared multiplied by 4 feet. So then my final answer would just be 24 times 4. So 24 times 4 gives me a total of 96. So the final volume would be 96 feet cubed. So that means that if we take boxes that are each box 1 foot by 1 foot by 1 foot, 96 of those boxes would fit inside of this pyramid, triangular pyramid. Okay. Example 7, like I said, it's the exact same thing that we've been doing. This is the same thing as finding the area of a cylinder, except that at the end we divide it by 3 also because the volume of a cylinder, this fits 1/3 of what a cylinder would fit. So to find the volume of this figure, we basically take a cylinder and then divide it by 3 at the end. So let's do it the exact same way we did the other problem. So let's mark it up and let's make one single slice. So if I were to take the slice of the base here, the base would be a circle. And even if you didn't know anything else, you should know that for this base, the area formula would be pi times the radius squared, right? So that formula would be pi r squared because it is a circle. So b is equal to pi r squared. Now we just actually have to figure out some numbers here. So the radius is half of 18 because 18 is the diameter. Diameter is from one edge of the circle to the other. So then we can figure out that this is going to be 3.14, which is pi, multiplied by 9, which is the radius, squared. So when I simplify this, I get 3.14 multiplied by 9 times 9, which is 81. And then the rest is calculator work. This is going to give me 81 times 3.14. So 81 times 3.14 is going to give me 254.34. So 254.34. And again, this is miles. So I'm going to go ahead and write miles squared. Don't forget the units. Okay. Now this is the formula for the base. This is actually not a cylinder though. The name of the shape is called a cone. And the formula for a cone is basically a third of a cylinder. So the volume formula is you take the area of the base, multiply it by the height, and then divide it by 3. Right? So you take the area of the base, which we just found, you multiply it by the height, which they give us, and then we divide it by 3 at the end. So one of these slices is a circle. We just found the area of that was 254.34. That's what we just established here. The height is given to us as well. The height is 18 miles, right? So the distance from the little point of that cone all the way to the bottom of the cone is 18 miles. So that belongs here. And then the rest we can figure out. So the volume is 254.34 miles squared, multiplied by the height, which was 18 miles, and then divide everything by 3, because that's what the formula says. Again, the reason why we divide this by 3 is because this a third of what a cylinder fits, that's what a cone fits. So that's where the 3 comes from. So 254.34 times 18 divided by 3, my calculator says is 1,526.04. That looks pretty weird. Okay, let me fix that too. 1,526.04. I'm going to go ahead and just leave it because 04 is pretty close to 1,526 as miles cubed. So give or take 1,526 miles cubed. I rounded it down just a tad. Okay. So hopefully this is becoming clear and this is getting a little bit easier. I like using the area of the slice or the base when I do all my volume calculations. So hopefully you do that as well, and it becomes easier for you. The last one, it's pretty much going based off the formula because there's no way for us to be able to do it any other way because it's a circle, right? Or I should say a sphere, 3-dimensional circle all the way around, right? Or actually, better yet, ball. There you go. So the name of a shape, this is called a sphere, which is in math, that's what we call a ball. The formula for that, the volume of a sphere is 4/3 pi r cubed. So 4/3 pi r cubed. And if you go back, you can verify that formula. I give you the formulas in the beginning, 4/3 pi r cubed. So like we said, it holds twice as much as a cone, not as much as a cylinder. So it's kind of its own thing. So we basically just need the radius, and they give us the radius. So there's no science here. There's nothing that needs to be done in a fancy way. We just have to plug it in. The radius is equal to 7. So we get 7 times 7 times 7, right? Multiply it by 3.14, multiply it by 4, and then divide it by 3. So 7 times 7 times 7 times 3.14. And then we're going to multiply that by 4 and divide it by 3. So my final answer is 1,436. So volume is equal to 1,436. I rounded it a little bit. It's 0.02, but it's pretty darn close. This is centimeters cubed because we're talking about volume. So 1,436 of these little tiny boxes fit in this sphere. Okay, hopefully this video was informative. If you guys have any other questions, let me know. Have a good one.